there is an equation called the aerodynamic drag equation, which calculates the amount of force on some kind of object as it's passing through air. And this is extremely useful for anyone who's designing airplanes, rocket ships, cars, right? Anything that moves through air is going to find this equation useful. So let's talk about what it means. If you think about this conceptually, imagine the drag force, the amount of wind you're feeling on you. That's going to increase as the density of air gets thicker, right? That makes sense. If air were as thick as water, it would hurt a lot to have it blowing 50 miles an hour on your face, right? But air is not as dense as water. It's pretty thin. So it's uncomfortable, but you can deal with it. You can stick your head out the window of a car and not lose your head, right? Whereas 50 miles an hour of water, that would be a different story. Likewise, if you increase your velocity, then it's going to increase the force of drag quite a bit. If you increase your size, the area of an object, that will also increase the force of drag. So there's some cool relationships here implied by this equation. And all we want to know in this question is, if P is doubled, remember what P is. P is, oops, I used purple. That's not velocity. It is the density of air. If P is doubled, what's the effect on F? Well, let's plug it into our equation and see. So I'm going to write that equation over again. I'm going to say, here's my drag force equals my coefficient of drag times, not P, now it's 2P. And the other things are all staying the same. Velocity squared, area, and then divided by 2 here. What's the effect on drag? What has changed compared to your original equation? And you see, there it is. It's this times 2 thing. The drag force has been increased by 2. Okay? So that's all we're asking for here. We're just asking you to plug something in and see if you understand the relationship implied by an equation. Now, I want to give you another example because there's many varieties of this one. What if you had one where v was doubled, the velocity of something? Okay, so now in this case, the air density is the same, and whatever object it is, let's say an airplane, the pilot just stepped on the gas and doubled the velocity of the plane. Well, instead of v, now you have 2v squared, right? You have twice the velocity. And because that is squaring, look at what happens to that. That's going to turn into 4v squared with all the other stuff. You square the 2 and you square the 4. So in this example right here, if you compare it to the original equation, you see it's now 4 times bigger, not 2 times bigger. So depending on which one of those variables gets doubled or cut in half, those are going to have some interesting effects on the amount of force that's contacting that object from the air drag.